Hello everyone, this is the second part of the chapter 5. Since last time we mentioned that there are a couple problems still left with the PageRank. For example, the PageRank can only handle the generic popularity of a page, ignores the topic-specific authorities, and also the PageRank are using a single measure of importance, ignores the models of importance regarding the hubs and authorities nodes. And also the PageRank is still susceptible to link span, which can be easily attacked by the farm. Okay, so now this lecture will tackle the three challenges one by one. So the first is the topic-specific PageRank. As to the details about the topic-specific PageRank, we need to answer this question instead of generic popularity. Can we measure popularity within a topic? The target is to evaluate web pages not just according to their popularity, but also how close they are to a particular topic. For example, if we are talking about a topic in sports or in history. And another situation is that we should allow such queries to be answered based on the interest of user. For example, a query regarding the Trojan wants different pages, depends on whether you are interested in sports history and computer securities. So as we know, the random walkers has a small probability of teleporting at any step. So the teleport can go to the standard PageRank that any page with equal probability, so as to avoid dead end and spider track problems as we discussed before. And the topic-specific PageRank is designed to process a topic-specific set of relevant pages together with the teleport set as well. So the general design idea is that we should base the random walk so as to integrate the random walk into the integrated the teleport in this new PageRank algorithms. So when the worker teleports, the worker can pick up a page from a set S, and then this set contains only pages that are relevant to the topic. And also for each teleport set, we will get different vectors. As to the implementation details in the matrix formulation, we notice that the PageRank formulation has been updated with this new formulation here, especially the part in blue colors. So the A matrix is still stochastic, and so in this formulation, all the pages are weighted in the teleport set as equally. So we also can assign different weight to pages, although we generally start with evenly assigned weight as well. So in this case, the A matrix can still be computed as regular PageRank, for example, using the iteration methodology and multiplied with m, then added with an vector still maintains sparseness. So here is an example of the topic-specific rank. Suppose S has only one element, 1. The beta equals 0.8. So we get this image, and we note each node here, and after each node iteration, the first the iteration was initialized with even numbers and values, and after iterations we can probably find the stable values for each node. In the meantime, we can still calculate the S and the beta accordingly, and we got the similar the different R and vectors, and also we finally we conclude this version. We got the similar results as the iteration results. So another new question popping up is that how can we discover the topic vectors? Since we are talking about the topic specific, so how about the topic vectors? So first we can apply the different page ranks for different topics. Although we got the topics, the 16 top level categories such as arts, business, sports, agriculture, and etc. in the search engine applies. So as to which topic ranking to use, there is some strategies. First, the user can pick from a menu, and also to classify a query into a topic. Then we can use this context of the query to specify the area the topic the queries belongs to. For example, if the query is launched from the web page talking about a known topic, and also history of the queries regarding the basketball followed by Jordan, so there is no so such kind of context will provide very much useful information to specify the topic as well. Okay, now here is some issues regarding the application to measuring the proximity of graphs. As we know, the random walk with restart S still is a single element as we discussed before. So the first issue is the proximity of graphs. So as illustrated in this image, the proximity also known as the relevancy, closeness and similarity between the node A and B. And a good question is how can we measure proximity to determine whether the proximity is good or bad. So the first conclusion is that the shortest path is not good. So we and also no effect of degree 1 and such as E, F, G will take effect. So we really need the multifaceted relationships, such as which the D are very probably plays a very important role to determine the good proximity measures. And also the workflow is not good. So both the shortest part and the workflow is the path we should avoid. We should avoid to use in the evaluation of proximity. So the good one should be look like this. First, it will contain multiple connections between A and B, which means that there are connections in various aspects, and the quality of the connection is strong and also involves direct connections and indirect connections, and also the length and the degrees and the weight should be more various in this graph. Okay, so this is a good sign of the good property. Okay, so in that case, we probably pops another new algorithm regarding the similarity rank called Sing rank. And as we know, the random walks from a fixed node on k-partite graphs. If we setting the k-partite graph with k types of nodes, so such as authors, conferences, tags. So the topic-specific PageRank from node U can be expressed using the teleport set equals to the U as a set of U's. The resulting scores can be used to measure the similarity to the node U. So the problem is that this process must be done once for each unit because we need to process all the nodes in as a one set, and it is also suitable for sub-web scale applications, although which it can cause some kind of Bayes problems, but still applicable in some kind of instances. Here is an example about the Sing rank. So we need the question is what is the most related conference to the ICDM? As we know, all the conference listed here are the very famous academic conference in this area. To answer this question, we need to using the topic-specific PageRank with the teleport S. Suppose the S equals to the ICDM to find out which conference is the closest conference to this set. Okay, so the determination algorithms will also be applied to this information regarding the conference and authors. Okay, so after the computation with the topic-specific PageRank with IJDM set, we got the following figures here from 0.4 to 0.11. So we probably know that the KDD and the SDM are the closest conference to the ICDM. So here is a small summary regarding the PageRank. As we can recall, the normal PageRank applies the teleport to uniformly solve the spider traps and dead end at random or to any node, and all nodes should have the same probability of surfing landing where the set has evenly assigned values. Okay. As to the topic-specific PageRank, also known as personalized PageRank, the teleport trick is used to determine a topic-specific set of pages, and the nodes in this algorithm have different probabilities of surfer landing there. So we can see the S contains a different weight in each vector version dimensions. Well, the random walk with restarts. The topic-specific PageRank, where the teleport is always the same node, the S equals to 1 for the specific topic. Okay, so the next issue is how can we fight the web spam with trust rank, as we know, the web spam has been very has been so much across the internet, and the web. So the purpose of spanning is that any deliberate action to boost a web page's position in search engine results in commensurate the page's real value. I believe that the span has a very a glorious name like SEO, search engine optimization, which actually take the advantage of the pitfalls of the page rank. Okay. So anyway, SEO is probably an industry terms for the span, but the span is really nothing good, just to exaggerated the relationship of the web page content with searching keywords. Approximately there is about 10 to 15 web pages are spam. I assume this is quite optimistic estimation regarding the web pages. So in the early stage of search engines, the search engines will using a crawler to collect the information and update it, the index pages by the word they contains, and they also should respond to the search queries list issued by the users. So, and also in the early page ranking algorithms, the algorithm always attempt to order pages matching search query by importance. So first search engine considered is the number of times the query word appeared in the page, and also the second is the prominence of words position. For example, if the words appears in the title, in the header, or etc., very important positions, high score will be awarded to this page. As to the first generation of spanners, when people began to use search engines to find the things on the web, those who with commercial interest and purposes try to exploit a search engine to bring people to their own sites. This is a kind of traffic redirections or traffic attractions, whether they want it or not. I don't believe this is a good thing to the web user. For example, the shirt seller might still pretend to be about a movie website, so that it can redirect all the movie fans to the shirt sale website. So the only techniques to achieve high relevance and importance for the web page. So a more direct methodology is using the term to create the term spans. So how do you make your page appear to be about movies? What's your thought? Very simple and popular ways is that we can add the word movie 1,000 times to your page. We can also set color to the background color, so not only search engines would see it. So that is a very really tricky, that the text color that means the text cannot be viewed by the person, but can be understood by the search engine. Okay. So also the second thought is that you can run the query movie on your target search engine and to see what pages come first in the listing. And in that case, you copy the page into your page, make it invisible. This is very simple, tricky, and very useful in a very early stage in the for the term span. So how the Google tackles the term span? We believe that people say about you, and rather than what you say about yourself. So the Google solution is that trust the third-party comments. So using the Google applies the words in the anchor text, the word that appear underlined to represent the link, which means that the link is outside the current page and also its surrounding text. So in this case, the page rank is a tool to measure the importance of web pages. How this works? You probably would think about the PageRank, the algorithm itself. The PageRank are using the outlink to comments. Using the incoming links to comment the importance of this web page. So in this case, our hypothetical shirt seller will lose his purpose, saying that if he is about movies, he doesn't help because others don't say he is about movies. Only who you say he says he is about movies. So his page is not very important, so it won't be ranked high for shirts or movies. So a very direct example here is that, for example, the shirt seller create 1,000 pages, each links to his with movie in the anchor text. So while these pages have no incoming links, so they still get little page rank scores. So in that case, the shirt seller cannot beat the truly important movie pages. Okay, so that's a simple methodology implemented by the Google. Here is some instances or search results from the Google. Okay. Well, there is always something can be applied to for span and for the business and for the benefit. So the second technology to increase to boost the personal web page is span farming. So this is a kind of round two contradiction between the search engine and the spanners. Okay, so once the Google has become the dominant search engine, so many spanners began to work out the ways to fool Google, and means that if Google can be fooled, not other search engines, especially the Google has the most search traffic in the web. So the span farms was developed to concentrate page rank on a single page. Okay. In the span farm, link spans are created so as to boost a page rank on a particular page. So here is more detail about the link spanning. Link spanning, we are the link spanning is totally different with the term spanning. Okay. There are three kinds of web pages from the spanner's point of view. The first one is inaccessible pages. So it is not the target of the spanner. And the second is the accessible pages. For example, all these blog comments and the spanners can post links to the blog, follow the blog, while the links are actually direct to his own pages. The third is the owned pages, which is completely controlled or even created by the spanner, and many span multiple domain names so as to verify their from each other. So here is how the link farms are created. The goal is to maximize the page rank of the target page T. So the technical details is that if we can get as many links from accessible pages as possible to the target T, and we can also construct a link farm to get page rank multiplier effect. Okay, the details still sounds very abstract. So we are going to using an example to illustrate such kind of methodologies. So this is link farm. Okay, one of the most common and effective organization for the link farm. If we look from the first, we got the green target T. The first thing is that we can using the owned pages, probably millions of farm pages, to direct to the target T, and also we post the links to the T to the blog comments area, so to make all these accessible pages link to the T as well. So in that case, the target T will have both the accessible pages, which is actually the third-party pages who says T it is, and also has in links from the spanner owned web pages. So in that case, if we're using the X to present the page rank contributed by accessible pages, and Y is a true page rank value of the target T, and the Y equals X plus the following the amount which is contributed by the other pages. Okay. So as a conclusion, we can easily get the relation between Y and X here, Y and X here. So if we set out the beta equals to 0.85, so we can get the Y value like the multiplier effect for acquired page rank. So if we making the matrix large, we can make Y as large as we want. Okay, so the only thing is that if we put the beta bigger, much more closer to 1, so the Y could be larger enough. Okay, this is a very simple methodology regarding the trusted rank. Okay, so we still based on the trust rank, the trust rank first have to combating the term span using the analysis of text with statistical methods, and also similar to the user span filtering, which is also useful to detect approximate duplicates. Okay, that's kind of similar technologies. And also in the aspect of combating the link span, the detection and blacklisting all the structures that looks like spam farms, which leads to another compact in hiding and detecting spam farms trick. So the trust bank will include the topic specific rank with a teleport set of trusted pages. Of course, the trusted page does not including the term spam and the link spam. And also, the trust pages sometimes is very can be easily identified. Use some domains, for example, the .edu, which is a similar domain for all the educational organizations. So to construct the trust rank, the idea is to follow the basic principle, like using the approximate isolation here. It's always rare for a good page to point to a bad page. So we need to sample a set of seed pages from web, and also we can involve human judges to identify the good pages and also the spam pages in the seed site. This is a quite expensive task, so we must make the seed set as small as possible. So if let human examine a set of pages and decide which of them are trustworthy, we might pick up the pages of the highest page rank to examine, on the theory that while link spam can raise a page rank from the bottom to the middle of the pack. So it's essentially impossible to give a spam page on the page rank near the top of the list. And also we can pick a domain whose membership is also controlled, like the edu, gov. They are very limited usage regarding the domain name. If we go back to the seed here, as we said, we need to keep the seed as small as possible. So in that case, the trust has to be propagated based on the limited version of the seed. So if we call the subset of seed pages like good or trusted pages, we need to perform the topic sensitive page rank together with the teleport set equals to the trusted pages, so as to find the trusted pages similar pages, in that case to propagate such trust set regarding the links. And as to the practical solution is that we can use a threshold value and mark all the pages below the threshold as a spam, and while others are the trusted pages. So this is a very simple illustration regarding the trust propagation. The first step is that we set trust to each trusted page to 1, and suppose trust to the page P is assigned the number of TP. So each page has a set of outlinks present with OP. For each Q belongs to the outlinks, while the P confers the trust to the Q. In that case, the beta TP divide can be represented divided by the OP. So the trust is additive. The trust of P can be the sum of the trust converted by P. So the similarity to the topic specific page rank is that within a scaling factor, the trust rank is actually equal to the page rank, with the trust pages as a teleport set. Okay. So why the trust rank propagation is a good idea? Because the trust attenuation is degree of trust converted by the trust page will decreases with the distance in the graph. Okay, and also the trust can be splitted. The larger the number of the outlinks from page, the less scrutiny of the page author gives each outlink, just like the weight of the page spread their weights on their outlinks as well. So the trust is split across all these outlinks as page weights. So when picking up the seed size, there is other two conflicting considerations here. The first one is that human has to inspect each seed page, so seed size must be as small as possible because human, unlike machine, can read as much as possible. Humans are easily tired and may lose the right answer. The second thought is that we have to make sure every good page get adequate trust rank. So we need to make all the good pages reachable from the seed side by short passes. In that case, we won't we won't waste too much time in searching the good page. As to the practical approaches for picking a seed set, suppose we have to pick a seed set about K pages. How do we do that? First, we using the PageRank to pick up the top K pages by PageRank. As we said, the PageRank will provide the first round selection sets. A theory that you cannot get a bad page rank really high. That means the first round filtering. And in the second round, we can apply the trust domain names suffix to filter the proper and trusted URLs. Okay, so this is a very simple applications. Since we have been talking about the span combating, there is one issue we have left here is how much is the span in the web. So in the trust bank model, we start with good pages and try to propagate the trust. So we probably will get the feeling that only the good pages and the trust pages only occupied a small proportion in the web pages as well. So the idea is that how can we determine what fractions of a page rank comes from the span pages as well. Okay, so probably from this figure on the right corner, we can tell that we don't know all the span pages, so we need to estimate. Even with this estimation, we still get no exact number about the span mass. Okay. So the solution is that if using the RP to represent the page rank of page P, and RP plus represent the page rank of P with teleport into the trusted page only. Okay, in this case, you can think about the RP plus is an upgrade version of the RP. So what fraction of the page rank coming from the span pages can be represented with RP minus equals to RP minus RP plus. So the span mass can be evaluated with or estimated with this proportion, and P equals RP minus divided by RP. So pages with high span mass is still span. is still spam. So this is a very simple estimation. Okay, the conclusion we can get here is that spam are everywhere in the web, and actually are much more than the useful and trusted pages in the web. All right, there is a one issue left here we haven't talked about. It's about the authorities, the power of speech in the web. So regarding the power of speech in the web for the web pages, we have to consider the hits. The hit means hypertext-induced topic selection. It's a measure of importance of page or document similar to the page rank. And to realize that if we want to find some good newspapers, we do not need to find the newspapers. We need to find the experts, the people who link to a coordinated way to good newspapers. In that case, we can talking to some people know some area much better. So the idea is that we can using the links within the web pages as votes, as polls. Since the page is more important, so what if it has more links? So should we consider the incoming links or the outgoing links? So shall we start with finding newspapers? Say for each page we have two scores. One is used to record the quality as an expert, and also the other record the quality as content. So the principle is that we will repeatedly improve these algorithms. So in the hubs and the authorities, all the pages are actually fall into the following two categories. The first is the authorities, indicating the pages containing very useful and powerful information, and like the newspaper home pages, the course home pages, and also the home pages of all the auto manufacturers if you are looking for some automobiles. Well, the hubs are actually the pages that provide the link to the authorities. So in simple words, the authorities are nature powerful pages, while the hubs are the necessary paths direct to the authorities. So the hubs are including the list of the directories, and also as to the course bulletin, and also the list of the automobile manufacturers. So it's very easy to understand the hubs and the authorities. Now, how can we decide the authorities? We are using the incoming links to decide to pick up the authorities. So as the scoring of the authority and the hub are very interesting, here in this image we imply this policy that each page start with the hub. The hub is actually all these circles with no text is hubs. All the authorities will collect the votes from these hubs, which means that the votes will be the links start from the hub to the authorities. in that case, for example, the New York Times received 1, 2, 3, 4 links from other hubs. So the New York Times got 4 votes. Okay, and in the next round, all the hubs actually collect all the votes from these authorities. For example, this hub have links to the SJ Merck News, and also has the New York, has the Wall Street, has the USA Today. So that's a 2 plus 2 plus 4 plus 3. That's 11 coming from, and in the third round, the authorities again collect the hub scores again. So in that case, for example, the New York also collect from the 8, 11, and also from the 7, and also from the 5. So this is how we get the 31 from this process. So this is a very interesting recursive operations. In that case, a good hub will links to many good authorities, and also a good authority is actually linked from many good hubs. So this model applies to scores for each node. Both hubs and authority scores are used in these algorithms. So this is the algorithm in practical, and which applies the policy we have described before. So anyway, this process will keep iterating until it finally convergent, as we described in like before in the PageRank. Okay, and so as to the algorithm, we still have the initiation stage, and also we start with this authority to collect the scores from the hub, and we collect the hub scores from the authorities, and we also normalize these results, normalize this result among on authorities and hub each. Okay, so this process will be finalized until there is no much change according to the H and A respectively. So the hub and the authority finally will converge to a single stable point. We need to know that such a vector like A and H, they can express with the adjacency matrix A, and so as to the Aij will be 1 if they have links from I to J, 0 otherwise. So in that case, we can calculate all the H based on all the sigma I to J, and so in that case, the Hi can be rewrite with sigma Aij to Aj. So in that case, simplified as H equals to A multiplies the A. Similarly, we can represent the A vectors together with the transposed matrix A with H. With above notations, the His algorithm can be represented in the vector notations as shown in this slide. Okay, And as to the existence and uniqueness regarding this solution, we can express here under the reasonable assumption about the adjacency matrix His converges to the vector H star and A star. So the A star is actually the principal eigenvector of the matrix of A multiplied with A transpose, and A star is actually the principal eigenvector of the matrix A transpose multiplied with A. So here is an example of the heat. It's very simple connections between Yahoo, Amazon, and Microsoft. So we start from the initial A, H, and A, and finally we will reach convergence results of the Yahoo, Amazon, and Microsoft. Okay, so probably we noticed that the Microsoft and the Amazon Microsoft were more authority rather than the Amazon. Although Amazon was very popular for now. So as a conclusion, compare with PageRank and HEATS. PageRank and HEATS are two solutions to the same problems. Although PageRank has several deviations as the upgrading version. So what's the value of an incoming link from U to M? So this is another thought we are going to talk about. In the PageRank model, the value of the link depends the links into U, while in the HEATS model, it depends on the value of other links out of the U. So this is the most prominent difference between PageRank and HEATS in the computing philosophy. Okay, so the destinies of the PageRank and HEATS post 1998 were very different, and also there are much more recent and brilliant search engines and algorithm come into effect, but the PageRank and HEATS are still the very basic and foundational algorithm to understand the web pages. Okay, it's good for now, and thank you very much.